Hello, good afternoon, good morning, everybody. My name is Vishvadeep, and I welcome you all on Unacademy Computer Science channel for unlimited learning. We call here unlimited learning just because we provide you lots of opportunity for learning absolutely free on this particular channel in computer science domain, including your semester exam preparation, gate exam preparation, other any competitive exam preparation, including your machine learning too, plus placement preparation, and so much we provide here. That's why we call it as unlimited learning. In this particular lecture, I'm going to talk about most expected questions, part number 2. Yes, part number 1 we have already seen. Part number 2, as initially I thought, let's give you more questions, expected kind of questions which can be asked in any competitive exam from the tree data structure, but I have included some bonus questions also for you guys so that you can have a good capture, a large capture of most expected questions from our end. So without any delay, let's start the session and we will solve the questions together, me and you. Before we start, let me introduce myself. My name is Vishvadeep. I work as a team leader in Unacademy branch computer science team. I have written the GATE exam multiple times. 19, 119, 440, 682 are my ranks. I went for my masters to IISc Bangalore, visible here, and another masters from BITS Pilani in data science I had done. Then a rich experience of teaching. These are the courses I am teaching on Unacademy's platform: computer organization architecture, data structure, coding interview problems. If you guys are not aware of the Unacademy's platform, then you should definitely visit our unlimited learning platform. Yes, why we call it as unlimited? Just because right now the Unacademy is the India's largest online platform for learning, and on Unacademy we provide lots of free classes, free quizzes, and lot other content. So if you are not aware of that, just go to unacademy.com or download Unacademy app, Unacademy Learner app, follow my profile, and when you create your account, use this code VDEEP10 so that you can unlock all the free content. What are the free content? First of all, free classes, which we call as special classes. All these special classes are special just because these are absolutely free. All the educators will teach you on Unacademy special classes absolutely free. So you can attend my live classes, plus you can listen all my special taken classes in the recorded mode. Follow my profile and listen all the lectures live in more interactive manner on Unacademy's platform. If you want to have quizzes, questions, practice tests, and lot so many things we provide on Unacademy's platform which are absolutely free. Create your account and enjoy the free service. This, we have a test series absolutely free. Go for it, enroll for it, and enjoy the quality questions, the questions which we have curated for your learning as a free test series. Subject wise test we are having, and you can enjoy those tests with the quality question. If you want your preparation to be best, if you want that, yes, I am starting preparation of GATE, maybe 22, maybe 23, or you are in the middle of 21 or at the end of 21 GATE exam preparation, but still you are lacking in something. If you want your preparation to be on the best side, if you want that whatever you have learned, you can use that learning for problem solving in GATE exam, then you should have the more and more accurate, more precise, more concise, and more revised solution in your mind. And that particular solution we provide here on Unacademy's platform, that is Unacademy Plus. Unacademy Plus is our paid service where we provide you live classes in terms of batches. These live classes you can listen in the recorded mode later on once the classes are done. If you miss any class or if you want to revise, as many as times possible. So this is very unique facility of Unacademy side. We will not delete any video. You will be having those video access unlimited times. You can access those videos again and again and again. You can watch those videos so that your learning will always be good. Whatever you learn in the classes, we will provide you weekly tests and quizzes so that you can test yourself, whatever you are learning, you are able to implement that or not. You will be having lots of doubt solving from our end, so you will not carry any kind of doubt, any confusion in your mind. Hence your preparation will always be best. So Unacademy Plus is more structured, more organized and more motivated plan of the study we have and we are providing to you guys. So if you want to go for Unacademy Plus, you can take the subscription of Unacademy Plus in 1 month, for 3 months, 6 months, 12, 18 and 24 months package. If you want to take the subscription, you can get discount also if you use the code VDEEP10. But this particular code is not only the discount code, this is the code to get discount, plus this is the code through which you can connect your preparation to my team. Yes, it's a connection, it's a feel which you will have, which you will use to connect your preparation with my team's effort. There is a team of 8 members and soon it's gonna be more and more and more number of members in the team. So that particular team going to cover entire syllabus of GATE computer science, and that team will support you if you use the code VDEEP10 and get the Unacademy Plus subscription done. If you are the person who is not good enough to make the preparation strategies, to make the planning of your preparation, to analyze that where you are going wrong and what you can do better for your improvement, all these things from our end also we can provide if you go for Iconic subscription. This subscription has all the facility of Unacademy Plus, extra facility of personal coach. The personal coach will provide you preparation strategy, will provide you the study planning so that your performance can be tracked, will give you the personalized test analysis. You will be getting regular workshops and guidelines and booster sessions so that you can revise the continuously so that you can remember the topic more effectively. You will be getting extra practice sets and specialized notes. All these things come under Iconic subscription, and this particular Iconic subscription also you can get using this code so that you can get discount plus other benefits. This Iconic subscription comes in only 12 months and 24 months package. But remember, if you want to have your rank to be iconic, your college to be iconic for masters, go for subscription Iconic using the code VDEEP10 so that you can get the discount. Here are some batches. As you can see, top educators of the country are on the platform, are taking so many classes. You have benefit to take any class taken by any educator on Unacademy Plus once you subscribe Unacademy Plus. And this is the course which I have started as the last moment preparation. 10 to 12 marks asked from this particular course only. On an average, if you use the code VDEEP10 and get the subscription, you will be able to access this course which is going live on Unacademy Plus for computer organization and architecture. Now I want your answer. What? Are you ready for problem solving? These are the sessions which I am giving you so that you can get the questions and their solution together. But these are the practice questions, and these will have best meaning when you will do what? You will practice the questions along with me. I am not restricting this session only for the tree data structure. I have brought so many questions from different topics so that you can have a good practice over multiple questions, multiple topics and multiple types of concepts. So if you are ready, can you tell me you are ready? And then yes, we will solve the questions. So very first question, very easy question from the array data structure I have brought here for you. Consider a sorted array of integers. Mind the words, sorted array of integers of size n with duplicate elements. So you have duplicate elements, yes, and sorted array, yes, size n. You have been given an element k. So एक element हमको मिल गया. What is the time complexity to find that element is appeared at least n by 4 times in the array or not? So let's say, if suppose for example we take n is equal to 100, some value k is given, I'll have to check that this particular value k is present कम से कम मिनिमम n by 4 times means at least 25 times or not. I'll have to check that. How do I check it? How do I check it? But I'll have to check if that element, same element present 25 times or not. So I'll have to check out that how many times the element is present in the array. Do I do that? If I'll go with this, then I will have to go for 25 times checking, right? Listen this. I will give you one best solution for this one. I will provide the best solution for this one. Listen how you can think such kind of questions. Suppose this is the array, right? 0 to index n minus 1. You know that the array is sorted? Yes. So if element k is present more than one time, duplicate keys, all duplicate keys should be consecutive. सब एक साथ रखी होंगी. Just because the array is sorted? Yes or no? Yes or no? Yes. Now what you need to do? You need to have a modified binary search. You need to have a modified binary search. Now that modified binary search will do what? Suppose through binary search you have reached to the middle. You have reached to the mid. You check at mid if you have element k, or if you have element greater than k, then you should go towards left. ऐसा क्यों कर रहे हैं? ऐसा इसलिए कर रहे हैं just because, why we are doing this? Just because I want to check कि that element k is appearing in my array on which index first. First means suppose some element is here, then next element is here, some duplicate keys are there. Very first time, सबसे पहले ये element k, this element k has appeared on index number I. This I want to just get. So if at mid index I am getting k, might possible this is not the first appearance of k, so I'll go towards left. And if I am getting at middle element which is greater than k, तो of course तो और left में जाना है. So somehow I will modify my binary search algorithm in such a way that I can get the first appearance of element k at index I. मिल जाएगा. And how much time it takes? How much time it takes? Log in time. कैसे? अरे binary search लगाया ना, तो binary search can take log in time. So what I did is, first I have calculated first appearance. I have obtained the first appearance of element k. At which index? At index I. Some index I. उस index I पे in the sequence from 0 to next, that element k has appeared first in the sorted sequence. Now I know if that element is present 25 times, then it will be starting from I, then I plus 1 index also the same element k. Yes, I plus 2 also same element k. I plus 3 index also same element k. Yes, क्यों? Just because of array is sorted. So what I will do? Then I'll check first index I plus 1, I plus 2, I plus 3. ऐसे check करना है? No. I will have to conclude कि at least 25 times present है कि नहीं. So what I will check? I will check directly this कि if in the array at index I plus n by 4 minus 1 on this index also, if I have element same to same k, means I will return true. What I will return? True. हाँ जी, ये element more than at least 25 times, at least n by 4 times present है, otherwise नहीं. So you don't have to apply the linear search after first appearance. No, I know that I am checking only n by 4 times if the element is present or not. Array is sorted, then I will directly jump after n by 4 index which element is present. If at in n by 4 I plus n by 4 index also is having same element, means yes, that element is present at least n by 4 times, otherwise not. अब आप बोलोगे सर ये -1 क्यों किया? अगर I इंडेक्स से स्टार्ट होके मैं पूछता हूं कि 2 बार प्रेजेंट है कि नहीं एलिमेंट, तो कितना होगा? I plus 2 -1 only on index I, and on I plus 1 if that element is present, then हाँ मैं बोल दूंगा कि element is present 2 times. Yes, समझ में आया? Right? So I am going to check in my array I plus n by 4 minus 1, the same k element is present or not. If present, then true, or else I will return false. Now let's try to understand the complexity analysis. Let's do the complexity analysis. First appearance of element k has taken log n time, and after that this checking is taking only constant time. So can you tell me overall how much time required to check if an element is present n by 4 times or not? Answer is B, log n time. Understood this concept? Yes or no? This can be one of the question in the GATE exam. Yes, that's why I have kept this in the expected question list. I hope you understood that. Answer is B, log n. Fine. Okay, let's go for the next question then. Next question is draw the expression tree for the given following expression. Okay. Then here exponent is an exponential operator and it has right associativity. हाँ हमको पता है. This upward arrow. What is the height of the tree? Height of the tree with single node is 0. Okay. Let's calculate the height. So first of all, if you draw any expression tree, then you should understand that which operator you should resolve first based on the precedence. And if two operator having same precedence, then we should go for associativity. Okay, sure. Next, so what we are going to do first, exponent is having highest precedence among all, and exponent as given in the question also, and we know also that exponent has the right associativity. So first of all, rightmost this one 3 exponent 2 you need to solve. 3 exponent is having left operand 3, right operand 2. Now once this is done, then for this exponent you need to solve next precedence and associativity. Based on that, I am going to explain this one. I am going to solve this one. For this exponent, the right operand is the result of 3 exponent 2, left operand is 6. Now this is done, this much is done. After that, multiplication and division. What you gonna solve first? This multiplication. So let's solve 5 into 4 first. Why multiplication? Just because left associative multiplication division are both are having same precedence. Yes, left associative है इसलिए 5 into 4 you need to solve first. Okay, I am solving this multiplication. Left operand 5, right operand 4. Then after this, divide by result of this. So for division, left operand is this, right operand is this. Once now till this much I have solved, this much is done. After that 2 minus this. Why? Plus minus having same precedence, associativity is left to right. So first of all you're gonna solve left one minus. So for minus, left operand is 2, right operand is result of this entire sub expression. At the end, this sub expression plus 9. So plus left operand is this sub expression, right operand is 9. What is the height of this tree? When the single node height 0, 0, 1, then 2, then 3, then 4, and then 5. Answer is 5. Height of this particular tree is 5. Got it? Okay, chali. Fine. Next. Consider a singly linked list of n elements, n greater than 1. Okay, so at least 2 elements should be there in the linked list. And P be a pointer, okay, pointing to a node of the list. Fine. So in the linked list, there is a pointer P given. That pointer P is pointing to some node. The runtime complexity to insert a new node before the node pointed by P in the list is. So there is a list. Let's assume this. In the list, if suppose pointer P is pointing to some node, maybe this one or this one. Suppose this one. Or maybe some other. Maybe this one. Pointer P is pointing to some node. I'll have to insert a new node just before the node. Just before the node here. How much complexity is needed? So if I want to insert a new node here, what changes I'll have to make? Data I will copy here. Its next I will keep as pointer P. One more change I'll have to do, and this one is the change. The next of predecessor of P should point to my new node. Now the problem is, in the singly linked list, we cannot access the predecessor of P directly. You cannot do that. So what should I do? You will have to traverse from starting. Yes, you will have to traverse from starting through a pointer so that you can reach to the predecessor, and that traversal will take some time. How much time? As many as nodes we have before P. So in my worst case, how many nodes before P we can have? Almost all n nodes, n minus 1. If P is pointing to the last node, almost all. That's why the complexity is big O of n. So I'll have to have a traversal included so that I can reach to the predecessor of P, so that I can change this pointer, right? And for that, complexity is this. Okay, next. Consider an array of n elements. Fine. Holding the pre-ordered traversal of a height balanced binary search tree with n nodes. Height balanced means kind of an AVL tree. So it's not skewed tree. Okay, fine. And it's a pre-ordered traversal. Okay, fine. The worst time complexity of the best possible algorithm to find in order traversal of the tree is. I'll have to find out in order traversal of the tree from the given pre-order. For the general tree, can you get the in order directly from only pre-order? No. But for binary search tree, can you do that? Yes. Yes, I can do that. And what is the in order traversal? In order traversal of binary search tree is nothing but sorted sequence in ascending order, right? Now the thing is, I have an array which is having pre-order traversal, and that array I'll have to sort. That's it. So the problem has reduced to this n elements I'll have to sort. Best possible algorithm, worst time complexity. How much is the time? Best possible algorithm, worst time complexity. How much is the time? So how much is the time? Okay, there is a mistake here. C option should look like this, n log n. Log n दोनों एक नहीं होंगे. So if we will go for the comparison based sorting, maybe the heap sort or merge sort, then we should have the worst complexity C. N log n time. Yes, n log n. Okay, okay, got it, fine. So if we go for best possible algorithm, which is merge sort or heap sort, then you can go for n log n. Okay, clear, got it. Next one, the time complexity to insert an element at starting in a circular singly linked list is. Answer should be what? You tell me, what is the answer? What's your answer? तब तक मैं लिस्ट बना लेता हूं. बताओ रे बाबा, क्या आंसर आएगा रे, कितना आएगा? circular list. Okay, this is the circular list. Now, if suppose we want to insert a new node here at the starting, right? Then list, this particular new node will have data here. Its next should be pointed to this one. List should be pointed to this one. Insertion done? No. No, why? Just because look at this. This last node now should point to where? My new first node. New first node, yes. Do I know the address of last node? Do I know the address of the last node? No. Can I get that directly through the list pointer on new node or the first node? No. In that particular case, should I have a traversal? Yes. And to change the next pointer of the last node, I will have to have entire list traverse. Answer is C, theta of n time. So if any such question comes, इतना जल्दी conclusion पे मत आइए. Draw this kind of thing. Have something in your imagination. Yes, ऐसे operation करेंगे. Quickly just sort out the things that constant time में नहीं हो पाएगा. In constant time you cannot do that. I hope you understood this point. चलिए, next one. Another question of array. Consider an array A of -8 to 15. So -8 is nothing but lower bound of the array. And upper bound of the array, upper limit is index 15. Which is stored in the memory from address 500. So base address is given 500. And each element takes 4 locations in the memory for storage. Okay, so element size I denote it by W, which is equal to 4. All the numbers are in decimal. ठीक है, हमको भी वही पता है. Next, total number of elements in the array. How many total number of elements we can have in the array? So number of elements in the array can be what? Number of elements. How do you find number of elements? Number of elements is equal to upper bound minus lower bound plus 1. That is the simple formula, simple concept. So what is the upper bound? 15 minus lower bound minus 8 plus 1. Can you tell me how much it is? 24 elements. That's good. That's great. Second one. What is the second one? What is the address of element A of 9? I'll have to find out location of A of 9. Location of A of 9 can be what? Location of A of 9 should be this. Base 500 plus each element size 4 into index I9 minus lower bound minus 8. 9 plus 8, 17 into 4, 68. So it becomes 568. That is the answer for the second question. First question answer, second question answer. Good, good Shweta, Vedant, nice, super, super, nice. Sure. Next, आगे बढ़ेंगे. अगला question, next question. These are simple but effective question to understand that how you are going to approach the questions and how you are going to solve the questions. Which of the following statements about an array is or are true? MSQ type question. Insertion in sorted array takes big O of n time in worst case. Is it true? Yes. If suppose there is an array, in that I'll have to insert an element and that particular element is the smallest one. So how do you insert that smallest element? At the first place. But for that, remaining all elements you will have to shift backside. Already suppose you have option A. Suppose you have already like this 8, 15, 19 and 20. And in this one you need to insert suppose 6. Then what you need to do? First 20 you need to shift to the next index, then 19 here, then 15 here, then 8 here, so that you can insert the smallest element here. So in the sorted array, insertion may take big O of n time. Option A is correct. Correct one. Deletion in sorted array take big O of n time. Yes, that is also true. Worst case complexity in deletion in sorted array, of course, big O of n time. Next one. Searching in a sorted array takes big O of n time in worst case. Yes, sorted array है तो possible है, बिल्कुल है. That is also true. Searching in sorted array takes big O of n time in worst case. बिल्कुल correct है. If you are going to apply the binary search. Deletion in sorted array takes big O of n time in worst case. Wrong. So A, B, C are correct. Okay. Fine. Now the cases is not the choice of algorithm. Most of the student will ask me, sir, अगर मैंने यहाँ पे linear search use किया होता तो they are not talking about best case, worst case as the taking the algorithm or selection the algorithm. Selection of algorithm is different case. Worst case means type of input given to you. If sorted array is given, sorted array is given. So whether it is worst case or best case, in the sorted array, binary search will always take the time log n time. So choice of algorithm will not be the consideration in the best case or worst case. Best case and worst case are the type of input, not the type of algorithm you are selecting. Okay? Check. Another one. Consider the following post order in order traversal of the binary tree. Which of the following is the pre-order? There is a binary tree whose post order and in order given. You need to first draw the tree and then give the answer that which is the pre-order traversal of the tree. So what should you do? What should you do? You need to just draw the tree based on our method. What is the method? Post order will give you root. In order will give you left right subtree. So check the root of each subtree from post order, left and right subtree in order. So first of all, post order, you know that which symbol, first one is the root or last one is the root. Post order traversal, last symbol is root, A is root. So A is root, fine. Now, if A is root, then these B, C, D and X should be in the left, Y, F, G, E in the right. Okay, fine. Now, next, BDCX. BDCX, check it out here. What is the last symbol? Last symbol is B, so B is the root. If B is root, check out in order traversal. BDCX, BDCX in order traversal. Here B is this, means DCX in the right. DCX in the right. Right of A. Right of A, YFGE. YFGE. Check out YFGE. Which is the last symbol? Which is the last symbol? Which is the last symbol? Try to do that by yourself. आप लोग भी करिए. E is the last symbol. So E is root. Fine. E is root. Now if E is root, check out the in order traversal. As compared to E, where are the other fellas? FGE in the left. FG. Okay. YFG in the left. YFG in the left. Fine. Nikhil. Very good morning, Nikhil. Next. DCX. Now let's check out DCX. Let's check out, oh, ये क्या किया? A, B. DCX, which is the last symbol? C. So C is the root. If C is root, then check out D in the left, X in the right. D in the left, X in the right. Next, here in the right side, FGE. FGE in the post order traversal, you check. FG in the post order traversal. Okay, FGY. FGY here. GFY. Last symbol is F. Last symbol is F. F is root. If F is root, Y in the left, G in the right. Y in the left, G in the right. That is the tree. That is the tree. Now it's Pre-order traversal I'll have to take. Pre-order is A, B, C, D, X. A, B, C, D, X. Then E, F, Y, G. E, F, Y, G. A, B, C, D, X, E, F, Y, G. Option C seems correct. Good. Priyank, nice. Siddesh, good one. Good, really good. Very simple. These are the methods we always solve in the classroom. Do it, apply it, get the tree, get the answer. Very simple. Next one. How many different binary trees can be formulated using four distinct keys? Four distinct keys. Let's assume the keys are 1, 2, 3, 4. These are the four different keys. How many binary trees can be constructed? So first of all, number of binary trees using n unlabeled nodes will be how many? Catalan number 2n cn divided by n plus 1 for n number of nodes. But if they are asking number of binary trees using n distinct keys, so that will be each such tree can be populated with these keys by n factorial. By n factorial. So answer will be 2n cn divided by n plus 1 into n factorial. That will be the answer. So Catalan number will give you number of binary trees formulated using n unlabeled nodes, bina label k. How many such kind of tree you can construct, different structure, those will be Catalan number. But अगर answer दे रखा है, question दे रखा है 4 distinct keys, then if you want to populate these keys in a binary tree for each such structure, suppose this is the structure. In this structure, I have n factorial possibilities to copy the content. So my answer should be this. N ka value 4, 8c4 divided by 5 into 4 factorial. And that will be 14 into 24. Can somebody calculate how much it is? (336). 336 number of trees you can formulate using 4 distinct keys. That's the answer. Why? Just because we are formulating only binary trees, general tree. Okay. Now, next one. How many different binary search trees can be formulated using 4 distinct keys? अब बात आई है बाइनरी सर्च ट्री की, तो बाइनरी सर्च ट्री का आंसर होगा इक्वल टू 2n cn divided by n plus 1. These are the structures, and if you want to populate the keys in these structure, for each structure only one possibility, so that the tree becomes BST. इसका एक्सप्लेनेशन मैंने अपनी क्लास में बहुत डिटेल में बताया है. चेक आउट दैट वीडियो इफ यू हैवंट सीन. गो टू दिस चैनल अनअकैडमी कंप्यूटर साइंस, गो टू द प्लेलिस्ट सेक्शन, then go for the data structure playlist. In that you just check out one video of binary tree, binary search tree, binary search tree. I have explained all these beautifully. Now for this one, my answer should be 8c4 divided by 5. Answer is 14. Yes, 14 BSTs only. Correct. Binary search trees only 14. Just because we have a lot of restrictions in binary search tree. For every node, left subtree should contain lesser values, right subtree should contain greater values. बढ़ते हैं आगे. अगला प्रश्न बहुत आसान है. इसका आंसर मुझे चाहिए कि आप लोग देंगे. I want you to give the answer of this question. It should be n square. Okay, let me rewrite it. Big O of n square. Suppose an array contains n integers, each of which is either 0 or 1. Fine. Then the array can be sorted in how much time? So array is having only zeros and ones. You need to sort the array. You need to sort the array. Then tell me that how much time you will take to sort the array. You tell me the answer. आप लोग बताएं क्या होगा आंसर. My answer is this C, log n time. Most of you will think of one particular solution which I am going to tell you now. There are two methods to do that. As of now, I can tell you two methods to do that. Method number one. Count number of zeros and number of ones by one traversal. एक ट्रैवर्सल में पूरा एरे ट्रैवर्स करो. हाउ मेनी जीरोस आर देयर, हाउ मेनी वंस आर देयर, काउंट इट, एंड देन कॉपी, or I should say initially as many as zeros you have, initially zeros and then ones you update. If suppose some k number of zeros you are having, then in the array initially k times 0 0 0 0 0 0 you copy, and then remaining 1 1 1 1 1 1 you copy. Very simple, right? But in this particular case, you will require two traversals of entire array. दो बार traversal करना पड़ेगा. The question is, if COA playlist is sufficient for gate? Yes, COA full playlist of 53 lecture is more than sufficient for gate. Two traversals. But if you want to go for one traversal, then another method we have. In the array, you start two indexes, I and j. Stop I for element 1 and j will come this side. I will start from index first and will go this side. J will start from here and will go from this side. Stop I for 1. Stop j for 0. Wherever you find 0, you just stop j there. Wherever you find 1, you stop I there, and then swap those two. It's exactly same as your partition algorithm of quick sort. आपको पता है, right? Understand? It is exactly same as partition algorithm of your quick sort. Here you are not having any pivot element. You are just having two types of element. Starting, say, first one you find, from last you find first 0, swap these. So zeros will come starting, 1 will go in the back, and keep doing that till, keep doing this till what? Keep repeating this till I is less than or equal to j. Once I and j crossed, stop that. Your array is sorted and only one traversal. In this particular method, only one traversal required. Yes, complexity wise it's fine, but if your array size is too large, बहुत बड़ा होगा array size, then two traversals also will take a lot of time and it will impact your performance of the system. So this can be even better solution. Okay, fine. Sure. So answer should be N. Got it? Next one. Consider a binary search tree T with distinct keys. Fine. The right subtree of a node X in the T is empty. So in a BST, some node X is there. Suppose this is X. Some node X is there. This is X. And its right subtree is null. There is no any right subtree of that node. Fine. No any right subtree. It's null. and the node has an in order successor. Node has an in order successor. In order successor means the node has an element which is greater than that element. In the in order traversal, we know that the in order traversal is nothing but sorted sequence. So if suppose we have some elements and the node x is having some element, let's say k, then we should have some element, at least one element which is greater than k. That is the in order successor. Node has x has an in order successor y. Fine. Minimum number of ancestors the node x is having is. How many minimum number of ancestors the node x can have? First of all, if node x is having in order successor, means it is in the left subtree of its ancestor. I will tell you. 15, 10, 5. The right child of 10 is what? Null. So for me here in my example, x is 10. X is pointing to 10. Fine. Its right child is null. Yes. Do we have successor of 10? Yes. The in order traversal of this will be 5, 10, 15. 5, 10, 15. Fine. Okay. So in order successor of 10 we have? Yes. How many ancestor 10 is having? At least one. Then only we can have the in order successor of 10. Fine. Every node is considered to be its own ancestor. 10 is its own ancestor also, and 15 also the 10's ancestor. Total minimum how many ancestor 10 can have? Answer is 2. 10 itself and 15 in my example. तो अगर किसी नोड का राइट चाइल्ड नल है और तो भी वो नोड का एंसेस्टर या नोड का इन ऑर्डर सक्सेसर प्रेजेंट है, मतलब कि ये जो नोड x हमने मानी है ये किसी ऊपर वाली नोड के लेफ्ट में है. देखा मैंने एग्जाम्पल करके बताया. राइट गॉट दैट. अब बात आती है कि कितने और ऊपर एंसेस्टर हो सकते हैं. बहुत सारे हो सकते थे, बट मिनिमम पूछा है तो कम से कम एक नोड तो प्रेजेंट है. क्यों प्रेजेंट है? अगर ये नोड भी नहीं होती और 10 रूट होता तो फिर 10 से बड़ी वैल्यू कुछ नहीं होती, और 10 से बड़ी वैल्यू अगर कुछ नहीं होती तो इन ऑर्डर सक्सेसर कहां से आता? उन्होंने बोला है कि इन ऑर्डर सक्सेसर है, मतलब 10 के ऊपर बड़ी वैल्यू है. कम से कम एक तो चाहिए ऊपर बड़ी वैल्यू. ठीक है, तो नोड x के कितने एंसेस्टर हुए? 2. एक नोड खुद और उसका सक्सेसर 2 मिनिमम. बिल्कुल. क्वेश्चन पूछा सर एंसेस्टर तो पेरेंट होता है. हाँ, तो 10 का पेरेंट है ना 15. अब क्वेश्चन में मेंशन किया हुआ है कि खुद का पेरेंट या खुद का एंसेस्टर खुद को भी मानना है. गेट में भी ऐसा क्वेश्चन आया था डिसेंडेंट्स के लिए कि डिसेंडेंट खुद का खुद नोड है. हाँ, ऑफ कोर्स एंसेस्टर मतलब पूर्वज, हम भी उसी पर्टिकुलर वंश के हैं तो हमने अपने आप को भी उसी वंश के एंसेस्टर मान लिया. बिल्कुल पॉसिबल है. ठीक है, तो आंसर इस क्वेश्चन का आएगा क्या? 2. ओके, इस टाइप के ट्रिकी क्वेश्चन बनाए जा सकते हैं गेट में, बहुत आसानी से सॉल्व हो जाते हैं इफ यू अंडरस्टैंड द कोर कंसेप्ट ऑफ द टॉपिक. चलिए आगे बढ़ते हैं. A queue is implemented using two stacks S1 and S2 using the best possible algorithm. अब जैसे ही आप ये रीड करेंगे आपको मेरा लेक्चर याद आना चाहिए जिसमें मैंने बताया था कि ऑप्टिमाइज्ड वे में S1 एंड S2 के थ्रू आप कैसे दो स्टैक से इंप्लीमेंट करेंगे क्यू को. तो एल्गोरिथम में रिकॉल कराता हूं. इफ इंसर्शन पुश ऑन टू द स्टैक S1, अगर डिलीशन check if S2 is empty or not. If S2 is not empty, delete from S2. अगर S2 empty है तो S1 से S2 में सारे एलिमेंट लेके आओ और फिर वहां से पॉप कराओ S2 से सबसे ऊपर वाला एलिमेंट. दैट इज द बेस्ट पॉसिबल एल्गोरिथम जहां पे पुश एंड पॉप कम लगते हैं. ठीक है, चलिए अभी consider the following operation to be performed in an empty queue in that order. एक empty queue में इस order में हमें operation perform करने हैं. To perform above operations, minimum number of push and pop operations required are x and y. Value of x into y is. सबसे पहले NQ करते हैं. ठीक है, तो मैं एक एक करके सारे ऑप्शंस आपको बता देता हूं कि कैसे ऑपरेशन परफॉर्म होगा. सो ये ले लिए हमने 2 स्टैक. जब तक ये ऐसे स्टैक ऐसे ना बनाए ना, वर्टिकली ऊपर से खाली, तब तक सेटिस्फेक्शन नहीं मिलता है कि ये स्टैक है ना. S1 और S2. फर्स्ट ऑफ ऑल NQA. NQ के लिए सिंपल एल्गोरिदम, इंसर्शन इन S1. तो एक पुश लगा. तो अभी तक हमारे पास कितने पुश हुए? एक. NQB पुश करो, एक और पुश आ गया. NQC पुश कर दो S1 में, वन मोर पुश. DQ. अब अगर DQ करना है, वी नीड टू चेक S2 इज एम्प्टी. यस, इफ S2 इज एम्प्टी, वन बाय वन bring all elements from S1 to S2. If we need to say bring all elements from S1 to S2, 1 2 3 pops and 3 push. तो ये C B A हो जाएगा. And now what should we do? We should pop an element from A. तो एक और पॉप आएगा. टोटल 4 पॉप और एलिमेंट DQ हो गया A. देख सकते हैं आप, द फर्स्ट इंसर्टेड एलिमेंट डिलीटेड फ्रॉम आर क्यू. नाउ नेक्स्ट इज NQ. NQ किया E, तो एक पुश हुआ. देन NQF, एक और पुश हुआ. देन DQ, सिर्फ एक पॉप. वाई? इफ S2 इज नॉट एम्प्टी, वहीं से डायरेक्टली DQ करना है. आप देख सकते हैं B इज द सेकेंड इंसर्टेड एलिमेंट जो हमारे फ्रंट में रहना चाहिए. देन एक और DQ, C एक और पॉप हो गया. देन फिर एक और DQ. अब देखो S2 एम्प्टी है, जी हां, तो सारे एलिमेंट पहले S1 से S2 में लेके आओ. तो 2 पॉप और 2 पुश, 2 पॉप और 2 पुश, और साथ ही साथ एक और पॉप. कितने पुश हुए टोटल? X नंबर ऑफ पुश टोटल 3 4 5 6 7 8 9 10, and total number of pops are 3 4 5 6 7 8 9. The value of X into Y is how much? 90. आंसर इज 90. काफी सारे लोगों ने निकाल दिया है. बहुत अच्छी बात है, बहुत बढ़िया. दैट्स ग्रेट, अमेजिंग, सुपर सुपर, बहुत बढ़िया. इस तरीके से क्वेश्चन सॉल्व हो जाएगा. अब बात रही कि सर हमको तो ये एल्गोरिदम पता ही नहीं है. इस एल्गोरिदम के बेसिस पे एक बहुत 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 शानदार, बहुत टफ और बहुत ही अच्छा क्वेश्चन गेट में आया हुआ है. तो आप इस मेथड को डेफिनेटली सीखो, समझो कि ये कैसे काम करता है. इंटरव्यू के लिए भी बहुत बहुत अच्छी हो सकती है आपके. अगर इंटरव्यू में पूछा जाए कि स्टैक से क्यू कैसे इंप्लीमेंट करेंगे ऑप्टिमाइज्ड वे में, तो ये एल्गोरिदम आपको याद होनी चाहिए, बताना चाहिए. इस एल्गोरिदम का कोड, इस एल्गोरिदम का पूरा कंसेप्ट मैंने सब कुछ अपने क्लासरूम में बताया है. आप जरूर देखें उस चीज को, अगर नहीं देखा है तो. बढ़ते हैं आगे. एन इनपुट रिस्ट्रिक्टेड डबल एंडेड क्यू. पहले तो डबल एंडेड क्यू का मतलब बताओ. डबल एंडेड क्यू मतलब एक ऐसी क्यू जिसमें इंसर्शन और डिलीशन दोनों एंड से हो सकते हैं. इंसर्शन और डिलीशन दोनों एंड से हो सकते हैं. बट यह है इनपुट रिस्ट्रिक्टेड. इनपुट रिस्ट्रिक्टेड का मतलब होता है कि जो NQ है, द NQ इज रिस्ट्रिक्टेड टू ओनली इट्स स्टैंडर्ड एंड. यूजुअली क्यू में इनपुट कहां से लेते हैं? रियर एंड से. तो NQ सिर्फ और सिर्फ रियर एंड से होगा. और DQ कहां से हो सकता है? DQ दोनों एंड से हो सकता है. DQ is possible from both the ends. That is the input restricted double-ended queue. चल आगे बढ़ते हैं. following sequence of operations have been performed in that order. Okay, NQ rear, NQ rear, NQ front, DQ rear, NQ rear, कुछ ऑपरेशन दे रखे हैं. Assume that initially Q is empty, fine. Restricted operations are having no operation impact. मतलब अगर आपने NQ rear से कराया तो ठीक है, बट अगर NQ फ्रंट से करवाया तो नहीं हो पाएगा. क्यों? क्योंकि रिस्ट्रिक्टेड है ना. NQ इज रिस्ट्रिक्टेड ओनली फ्रॉम रियर एंड. अगर NQ आपने फ्रंट से कराया तो NQ नहीं होगा, NQ हो ही नहीं पाएगा. तो वही उन्होंने बोला है स्टेटमेंट में, क्वेश्चन में गिवन है कि रिस्ट्रिक्टेड ऑपरेशन हैविंग नो ऑपरेशन इंपैक्ट ऑन क्यू. मतलब कि अगर वो ऑपरेशन परफॉर्म करने गए तो क्यू में कुछ नहीं होना है. तो आप बताओ कि कितने एलिमेंट होंगे इस क्यू में जब पूरा एग्जीक्यूशन हो जाएगा. सबसे पहले एनक्यू रियर, तो 5 आपने रियर में इंसर्ट कराया. देन एनक्यू रियर 7, रियर से 7 एनक्यू हो सकता है. एनक्यू रियर से हो सकता है, बिल्कुल वही पॉसिबल है. एनक्यू फ्रंट 9, कुछ हो गया क्या इससे? नो ऑपरेशन होगा. व्हाई? जस्ट बिकॉज वी नो इनपुट रिस्ट्रिक्टेड में एनक्यू सिर्फ रियर से होगा. डीक्यू रियर, लास्ट से डीक्यू कर दो. लास्ट से डीक्यू करेंगे तो 7 डिलीट हो गया. फिर एनक्यू रियर 3, एनक्यू रियर 3, एनक्यू रियर 3, ये कर दिया. एनक्यू फ्रंट कोई ऑपरेशन नहीं, नो ऑपरेशन, क्योंकि फ्रंट से इंसर्शन नहीं हो सकता. एनक्यू रियर 8 बिल्कुल हो सकता है. देन डीक्यू फ्रॉम फ्रंट बिल्कुल कर दो. तो क्यू के एलिमेंट क्या बचे? 3 और 8, इनका सम निकाल लो. सम ऑफ ऑल एलिमेंट्स 3 प्लस 8. 3 प्लस 8 कितना हो गया? 11. दैट इज द आंसर. बस सिंपल है क्वेश्चन, बस आपको फॉलो करना है जो गिवन इंस्ट्रक्शंस दे रखे हैं वो, और आंसर मिल जाएगा इजीली. गॉट इट? आगे बढ़े. अगला प्रश्न ये रहा आपके कंप्यूटर स्क्रीन पर. हम दोनों मिलकर सॉल्व करेंगे. जी हां, आप सब मिलकर सॉल्व करेंगे. कंसिडर फॉलोइंग स्टेटमेंट्स. यू नीड टू से ट्रू और फॉल्स. Last symbol of in-order traversal of a binary tree is not a leaf. True or false? If in-order traversal of a binary tree you are giving, then it is possible that the last symbol is not a leaf node. Possible. Okay, so let's take a simple example. A, B and C. What is the in-order? B, A, C. Last symbol is C. It's a leaf node. Yes. But it is always? No. Why? Look at this. If suppose I have added a node here in the left, D. What is the in-order traversal of this one? B, A, D and C. Last symbol is C. Yes. Is it a leaf node? Is it a leaf node? No. First statement false. अब बोलोगे सर आपको आइडिया कैसे आया? आइडिया इस तरीके से आया कि पहले एक सिंपल सा एग्जाम्पल लिया. सिंपल से एग्जाम्पल में फिर हमने देखा कि सी सबसे लास्ट में आ रहा है. ठीक है, तो इसका लेफ्ट या राइट चाइल्ड बना के देख लिया कि क्या वो लीफ नोड होगा या नहीं होगा. लेफ्ट बना के देखा, राइट बना के देखा, नहीं आया. दोनों बना के देखे, नहीं आया, तो फॉल्स आ गया. फर्स्ट सिंबल ऑफ इन ऑर्डर ट्रेवर्सल ऑफ अ बाइनरी ट्री इज अ लीफ नोड. क्या सबसे पहले जो इन ऑर्डर ट्रेवर्सल में आएगा वो लीफ होगा? सबसे पहले तो सिंपल सा एग्जाम्पल ई रहा, तो इसमें इन ऑर्डर ट्रेवर्सल क्या आएगा? बी, ए, सी. तो फर्स्ट सिंबल बी, फर्स्ट सिंबल बी, यस. लीफ, यस. बट अगर ये बी के राइट चाइल्ड कुछ होता डी, तो व्हाट शुड बी द इन ऑर्डर ट्रेवर्सल नाउ? सबसे पहले क्या ट्रेवर्स करोगे? बी, देन डी, देन ए, देन सी. सबसे पहले आया ट्रेवर्सल में बी. क्या ये लीफ है? नो. आंसर इज फॉल्स. सेकेंड इज फॉल्स. लास्ट सिंबल ऑफ इन ऑर्डर ट्रेवर्सल of a binary tree is a leaf node. Okay, so first one is false. Why? Just because is not a लीफ नोड लिखा था. लीफ नोड हो भी सकता है, नहीं भी हो सकता है. सी इज ऑल्सो रॉन्ग. Last symbol of in-order traversal in a binary tree is a leaf node, not a leaf node. Both are possible. So always true or false we cannot say. I can say not always. Similarly, this also not always. Not always. हमेशा true होगा ये जरूरी नहीं है. It might be, it might not be. Might be, might not be. First symbol of in-order traversal of a binary tree is not a leaf node. Yes, possible, but not always. Got it? So both, all four option can be true, cannot be true. अगर स्टेटमेंट में होता लास्ट सिंबल ऑफ इन ऑर्डर ट्रेवर्सल ऑफ अ बाइनरी ट्री इज नॉट अ लीफ ऑलवेज और इज अ लीफ ऑलवेज, देन फॉल्स. I hope you guys are understanding what am I trying to say here. So it can be leaf, it cannot be a leaf. First and last सब कुछ. So आपको रीड करना होगा क्वेश्चन में कि ऑलवेज और नॉट. अगर क्वेश्चन में बोला है ऑलवेज, देन यू कैन से ऑलवेज फॉल्स. नहीं है ऑलवेज तो यू कैन से मे बी ट्रू. ओके, Jatin Agrawal, your guess was correct, sir. True or false? Yes, depends that they are asking about always or maybe may not be. चलो, ओके, आगे बढ़ते हैं. क्वेश्चन है कैन रूट बी अ लीफ? ऑफ कोर्स कैन रूट बी अ लीफ. एक सिंगल नोड है, ये रही, ये लीफ नोड है, ये देखो, ये ट्री है. ऑफ कोर्स इट कैन. आगे बढ़ते हैं. चलिए ये क्लियर कर देता हूं. नेक्स्ट क्वेश्चन बड़ा ही आसान क्वेश्चन है. Consider a binary tree T which has X number of nodes with one child and Y number of nodes with two children. Fine. If total number of nodes in T is N, then the value of N can be expressed as. We know that total number of nodes in binary tree is equal to total number of internal nodes plus total number of external nodes, leaf nodes. How many internal nodes? X number of internal nodes with one child plus Y number of internal node with two children plus how many external nodes we can have in a binary tree. Number of external nodes are always equal to number of nodes with two children plus one. Number of internal node with two children plus one. ये सिंपल सा एक लेमा है, हैंडशेकिंग लेमा. So how many total number of nodes n? X plus, ओहो प्लस लिख दिया, x नहीं लिखा, x plus 2y plus 1. बहुत शानदार. So many of you have given the correct answer too. Super. Sameer, Jatin, Shweta, Romit, Siddhesh. Good, great. Next. The total number of binary search trees can be constructed using 5 distinct keys so that the height of the tree is always 4. Height of a tree with single node is 0. So definition is given, height of the tree with single node is 0. How many different binary search trees can be constructed using 5 distinct keys so that the height is 4? So one type of tree you can have is this one. Height 4. Yes. you can switch this last node in the right also. No? Yes. Yes or no? Means, of course, I am just giving you some idea that what kind of different binary tree ke structure you can have. Suppose I am having n distinct keys, 5 distinct keys. 5 distinct keys are 1 2 3 4 5. First of all, this is the structure I can have of a binary tree, in which if I will put the values 1 2 3 4 5, 1 BST I can have 5 4 3 2 1, 5 4 3 1 and 2. Like this way you can have another BT. Similarly, you can have this particular node also in the left and right. Yes. This node also you can have in the left and right. Yes. This node also you can have in the left and right. Yes. So how many different binary tree combination you can have? How many different binary tree combination you can have? Let me first just tell you. Let me first just tell you with a small example. Let's say I am having n equals to 3 only. N equals to 3 only. So the downmost key you can have in the left, downmost node you can have in the right. Similarly, this also, with these left and right you can have two combination. In the right also you can keep this node, you can keep in the right, and this node you can keep in the right with this one. So on the root you have only one possibility. On the next level you have two possibility. On the next level you have two possibility. So on every level you can have two possibility. Just because the height is restricted, I will have to keep one node at each level. Height is 4, number of nodes are 5. One node at each level I'll have to keep, so that I can draw the tree based on the given scenario. So 1 2 3 4, 4 levels, each level 2 2 2 2 possibility. Answer will be 2 into 2 into 2 into 2. 16 different trees you can construct. And in each tree, if you put the value 5 keys distinct, 16 different trees you will be able to get. Answer is 16. Good, Romy. Nice. Super. Amazing. 16 will be the answer. Just because the height is restricted, I had to go with the answer 16. Hope you are understanding this. बहुत छोटे कंसेप्ट पे क्वेश्चन है हमारे, बहुत आसान से क्वेश्चन है. यही इसी टाइप के कहीं मिलते जुलते, कहीं थोड़ा इधर उधर का वेरिएशन से गेट में क्वेश्चन आने वाले हैं. तो अगर आप लोगों को कंसेप्ट सारे क्लियर है और याद है ऑन द टिप ऑफ योर माइंड, आप लोगों को कोई नहीं रोक सकता आईआईटी जाने से, कोई नहीं रोक सकता टॉप रैंक लाने से. कंसिडर अ हैश टेबल ऑफ साइज 11, इंडेक्स 0 to 10. फाइन. With linear probing and hash function h of k mod 11. The following keys are inserted in an empty hash table. Then which of the following is the correct option to denote empty indexes? तो आपको ये एलिमेंट इंसर्ट करने हैं using this function and linear probing, and you need to tell that what are the indexes which are empty. तो पहले तो एलिमेंट इंसर्ट कराते हैं एक एक करके. So this is the hash table I have drawn here. Index 0 1 2 3 4 5 6 7 8 9 10. मल्टीपल क्वेश्चन आ रहे हैं कि सर ऐसा होता तो क्या होता, वैसा होता तो क्या होता. आप अपने आप से पूछें इस टाइप के क्वेश्चन में और अपने आप से आंसर करें कि क्या होना चाहिए, और फिर आंसर वेरीफाई करवाओ किसी से. ज्यादा मजा आएगा, ज्यादा लर्निंग होगी और अच्छी लर्निंग होगी. सर हमने ऐसा सोचा, अगर ऐसा होता तो क्या ये आंसर करेक्ट है. अगर आप ऐसा करोगे तो शायद लर्निंग ज्यादा होगी. इंस्टेड ऑफ आस्किंग मी कि सर ऐसा होगा, तो आप ही बता दो आंसर क्या आएगा. ज्यादा मजा आएगा अगर आप खुद बताएंगे कि सर इसकी बजाय अगर हम बीटी होता, बाइनरी सर्च ट्री की जगह बाइनरी ट्री होता तो क्या होता. आप बताओ, आप खुद जानो और देखो कि क्या आपने आंसर जो निकाला है वो सही है या नहीं. कॉन्फिडेंस भी बढ़ेगा और नॉलेज और लर्निंग भी बहुत अच्छी होगी. चलिए क्वेश्चन पे आते हैं. इंडेक्स इज 0 to 10. फाइन function is k mod 11. first key is 6. 6 mod 11 is equal to 6. 6 फ्री है. जी हाँ फ्री है अभी तो. यहां पे 6 इंसर्ट हुआ. देन नेक्स्ट इज 17. 17 mod 11 is 6. बट 6 तो ऑक्यूपाइड है तो 6 प्लस 1 करेंगे. 7 ऑक्यूपाइड है क्या? नहीं. देन लीनियर प्रोबिंग के अकॉर्डिंग 17 विल बी इंसर्टेड एट 7. चलो आगे बढ़ते हैं. 2 2 mod 11 2. अब ये मॉड निकालना तो आपको आता होगा, मैथमेटिक्स के स्टूडेंट हो आप, है ना. एट लोकेशन 2. देन 63. 63 mod 11 कितना होता है? 55 प्लस 8 है ना. 8. तो लोकेशन 8 पे 63 विल बी इंसर्टेड. देन नेक्स्ट वन इज 81. 81 mod 11 कितना होगा? 81 mod 11 is 4. So at 4 81 will be inserted. Next 40. 40 mod 11 will give you 7. 33 plus 7. 7 is occupied. Yes. Then 8. 7 plus 1. 8 is also occupied. Then 8 plus 1 9. At 9 location 40 will be inserted. Then 28. 28 mod 11. 28 mod 11 will give you 6. 6 तो occupied है plus 1 7. वो भी occupied है plus 8. occupied है plus 1 9. occupied है. Then 28 will be inserted at location 10. What are the free indexes? 0 1 3 5. 0 1 3 and 5. 0 1 3 and 5. 0 1 5 true. Yes. 0 1 3 5 true. 1 3 5 also empty na. 1 4 5. 4 is occupied. 4 5 occupied. Okay, got it. Got it. So empty hash indexes are how many, and what are the empty? 0 is empty, 1 is empty, 3 is empty, 5 is empty. Am I making a mistake? Am I making a mistake? Okay. Oh yes, 9 I haven't inserted. 9 mod 11 will give you me 9. Oh ho. तो गड़बड़ हो गई, गड़बड़ हो गई, गड़बड़ हो गई, गड़बड़ हो गई. So before 28 I had to insert 9. Before 28 I had to insert 9. Let's recollect the answer. So let's go with the first 9. 9 mod 11 will give me 9. 9 is occupied, then plus 1 at 10. So index 10 will have the value 9, and after that 28. Oh, 28 will go to 0 then. 28 mod 11 will give me 6. Occupied 7, occupied 8, occupied 9, occupied 10, occupied, then it will go to 0. So 28 will be inserted at 0. So indexes, free indexes are only 1, 3 and 5. 1 3 5 B is correct. Yes, good. I made a mistake. Thank you so much for making my word correct here. So empty indexes are how many? 3. What are the empty indexes? 1, 3 and 5. That's cool. Got it. Understandable. Next one. Consider an array representation of heap with n elements as follows. Fine. Array representation we all know, right? Root at index 1. We know that. The left child of a node at index I, if stored at index, okay, the left child of a node at index I is stored at index 2i, means if a node is stored on I, its left child on 2i and right child on 2i plus 1. That we know always. Next, if the root is at level 0, then the level of an element A of I is what? Oh, so let's first draw a tree and take the array representation. So you know heap is a complete binary tree. Yes. So let's say this is the heap. Max heap I am taking. Max heap I am taking. So 10, then 6, 4, 3, 2, 1. This is the max heap. So root 10 will be inserted at the index 1. Then 6 and 4 will be inserted at 2 and 3. 6 ka left and right will be inserted at index 4 and 5. 2. And then at index 6 will be having 1. Let's talk about levels. This is level number 0. Then level number 1. And these are on level number 2. Right? So look at this. From here to here it is level number 0. From here to here level number 1. Here to here up to 7th index it should be level number 2. So if I have given you index 1, you should give me answer level is 0. If I have given you index 2 or 3, you should give me answer 1. If I have given index 4, 5, 6, 7, then you should give me answer 2. So what should be the correct answer? So let's go with this one. 4 के लिए 2, log of 4 is 2. 5 के लिए 2, log of 5 and its floor value 2. Log of 6, 2 point something, but 2 means it integer value, floor value. Log of 7, 2, yes. So answer should be log of index I and its floor value. If I will go with this one, look at this, index number 3. Index number 3, if I is 3, log of 3 is 1 point something, integer value is 1 plus 1, 2 दे दोगे आप. Or if you will go with I plus 1 first, 3 plus 1, 4, log of 4, you will give me 2. Answer is wrong. So B is not the correct one, definitely. Answer A is correct. Log of I and its floor value. Got it? Understood everybody? Is that clear? Is that clear? Next one. We have a recursion here. What is the value returned by call of function f of 5 when this is the function? 2 into f of n minus 1 plus n. Sure. So if n minus 1 is true, then we need to do this. So first of all, I have called function of 5. You know how to solve the question of recursion? You know, there is a question, Shreya Mukherjee, data structure full playlist. Yes, we have data structure full playlist under this channel, Unacademy Computer Science. Go to the channel, go to the playlist section. You will get a playlist of data structure. I have taken that. Some 36 lectures are there. You will be able to access all these lectures. Okay, Chali. Okay. Now, this one. Function 5 you have called. Recursion, whenever there is a question of recursion, I still solve all those recursive questions using a recursion tree, which is one of the best technique. So first of all, you have called function of 5. 5 minus 1, 4 is true. Yes. So return 2 into function of 4 plus n, which is value 5. Let's call for function of 4. 4 minus 1 is true. Yes. Then return 2 into function of 3 plus 4. Then function of 3 you have called. Function of 3, 3 minus 1 is true. Yes. Then return 2 into function of 2 plus 3. Function of 2 minus 1 is true. Yes. Then return 2 into function of 1 plus n की value 2. Then 1. When n is equal to 1, 1 minus 1 is true. No, false. Then in the false return 0. So f of 1 will return you 0 from here. 0 into 2 plus 2, 2. So this will be value 2. 2 into 2, 4 plus 3, 7. 7 into 2, 14 plus 4, 18. 18 into 2, 36 plus 5, it will return you 41. Good, good, nice, 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 nice. Mohak says, such an amazing comprehensive session, loving it so far. Wish I had found this channel earlier. Mohak, it's not too late, still you have a lot of time. Whatever the improvements you want, you can still learn from here. ओके, चलिए और अभी आगे बढ़ते हैं. अब आगे सारे क्वेश्चंस डन. वॉट एवर द एक्सपेक्टेड क्वेश्चंस, आई हैव ब्रॉट टू सीरीज फॉर यू. वन इज the first series in which we have already solved some 20 questions. Today also we have solved lots of questions. All those members who are preparing for gate 22 and 23, we are taking still some basic knowledge sessions for you. Subject wise strategy we are providing for gate 22 and 23 absolutely free on Unacademy's platform. If you are not aware about special classes on Unacademy platform, go to unacademy.com or download Unacademy's learner app and then use a code. Create your account using this code VDEEP10. Once you use the code using creating your account, at the time of creating your account, you will be able to access all the free classes. Search my name on Unacademy's platform, which is Vishvadeep, and you will be able to access all my free classes. सारी फ्री क्लासेस आपको एक्सेस करने को मिलेगी. ये जो क्लासेस हैं नो योर बेसिक्स, इसमें मैंने 2 सेशन लिए हैं. दोनों सेशन ऑलरेडी हो चुके हैं. आप देख सकते हैं कि कैसे यू विल प्रिपेयर द सब्जेक्ट वाइज स्ट्रेटेजी फॉर योर गेट 22 and 23. And if you want to have more details and links of that particular session, you can go to this official channel Unacademy Gate CS, and you will be able to access the PDF of our lectures, plus announcements from my team, plus all the new initiatives and all other news from my team you will be able to get from this Telegram channel. This is the team. These are the playlists which are already completed. COA, I have taken complete comprehensive course. It is having 53 lectures, and each lecture you will find worth if you will be watching that. Go and check out. You will definitely love that particular series. You are having series of theory of computation by Mallesham sir, Khalil sir operating system, discrete math by Satish Yadav sir, Pankaj sir ka computer network, and then machine learning by Arun sir. Then we have so many other lectures also, like C language by Mallesham sir, compiler design for him, and then data structure by me, then programming interview problems by me, and there are so many others. PYQ sessions, we have lots of playlists. We have, just check out the playlist section of this channel. You will get lot content to learn. बहुत कुछ सीखने को मिलेगा. Anybody who wants to join Unacademy Plus, once again I am telling you, there are so many benefits of joining Unacademy Plus. And if you want to join Unacademy Plus using this code, use this particular code so that you can get benefit of discount plus other benefit of using your preparation or attaching your preparation, connecting your preparation with my team. So if you want, use the code VDEEP10 and get your subscription of Unacademy Plus or Unacademy's iconic subscription, so that you can have your best quality learning in more appropriate, more organized, more productive manner. You don't have to push yourself hard a lot. We will do that. We will keep motivating you so that your structured learning can be good. If you want to be connected with us, we have Facebook pages also to be connected, and of course you have friends in other domain. Let them know we have channels for electrical, ECIN, Creatrix channel. Let them know your friends that we have mechanical channel also. There we are providing free education from the top educators of country, every domain. For civil, we have Gate CE channel. We have computer science, your own channel. If you haven't subscribed, subscribe it and watch the lectures over here so that you can learn lot and a lot. SSC JE channel, GS terminal channel for RRB and SSC for general study. If you haven't liked the video, please सेशन को लाइक कर दो यार, सब्सक्राइब कर लो एंड ये घंटी बजा दो ताकि जब भी मैं क्लास लेने आऊं आपके फोन की घंटी बजती रहे. एंड please share these lectures with all of your friends so that these lectures will be available to maximum number of community of the members so that those people can be benefited. सारे lectures playlist इस चैनल की लिंक्स को शेयर करते रहो. थैंक यू सो मच फॉर ज्वाइनिंग हियर. एनी काइंड ऑफ क्वेरी क्वेश्चन यू हैव, you can find me over Unacademy, and there you have an option to send a message to educator. So if you want to be connected with me personally, go to unacademy.com और learner app पे आप मुझे मैसेज सेंड कर सकते हो आपको अगर कोई प्रॉब्लम क्वेरी क्वेश्चन है रिगार्डिंग योर प्रिपरेशन. दैट्स माय फेवरेट कोट जो मैं हमेशा आपको बोलता हूँ, लर्निंग हमेशा रखो, हमेशा खुशी खुशी लर्निंग करो ताकि उस लर्निंग का आप यूज कर सकें अपने करियर बिल्डिंग में, अपनी प्रॉब्लम सॉल्विंग में, और आगे जितने भी प्रॉब्लम आप फेस करेंगे अपने करियर में उन सब के लिए. थैंक यू सो मच फॉर ज्वाइनिंग. वी विल सी यू soon in the next class. Till then, see you. Have a nice remaining day. Bye bye.